we will discuss soil mechanics, chapter number 2, classification of soil, engineering service exam, ESE, PYQ. Okay, so this is first question. Let us discuss first question. The standard plasticity chart to classify fine-grained soil is shown in the given figure. The area marked X represent silt of low plasticity, clay of high plasticity, organic soil of medium plasticity, and clay of intermediate plasticity. So let me draw the graph first. This is I plasticity index, and this is liquid limit W. And the equation of this line is IP is equal to 0.73 liquid limit WL minus 20, and this line is called A line. And if you put WL 0, if you put IP 0, then you will have WL is equal to 20. So this value is 20. And if we take this as 30 and this as 50, let me draw a line corresponding to 30 and 50. This is the line. I'm taking black color, and this is 50. This line is corresponding to liquid limit 50. Extend this line further. Okay, and this line also, and value of IP from 4 to 7 dual character. Okay, if soil is above A line, and before this line, that is line corresponding to 30, liquid limit 30, so this is termed as clay of low plasticity, and this region is in between liquid limit 30 to 50 and above A line. This is clay of intermediate plasticity, and this region after line, that line is at 50 and above A line, that this region is the soil in this region is called clay of high plasticity. Similarly, in this region, if the soil is in this region, then the soil is called so if the soil lie in this range below A line and after this line, that is the line corresponding to liquid limit 50. It is silt of high plasticity or organic soil with high plasticity, and this is silt of intermediate plasticity or organic soil with intermediate plasticity, and this is silt with low plasticity or organic soil with low plasticity. Okay, so this region here, this region is X, and X is clay of intermediate plasticity. So answer will be D. So answer will be D. Okay, answer will be D. Here CH is what? CH is clay of high plasticity, clay of high plasticity, that is CH. Ci is clay of intermediate plasticity, Ci. Cl is clay of low plasticity, that is Cl. Mh is silt of high plasticity, Mh. Mi is silt of intermediate plasticity, Ml is silt of low plasticity, Ml. OH is organic soil of high plasticity. OI is organic soil of intermediate plasticity, and OL is organic soil of low plasticity. Okay, so for this answer will be D. Okay? So the next question is question number 2. Question number 2. So what is question number 2? Question number 2 is saying a soil has liquid limit of 45. Soil has liquid limit of 45% and lies above A line plotted on plasticity chart. So the soil, this is 20, this is 30, this is 50, this is 50, this is 50, this is 20, IP, and 45, and above this line. So this will be the region. This will be the region. Okay, and in this region, soil is called what? Ci. So answer will be B. Second answer will be B. Okay, question number 2. Now question number 3. Now question number 3. Question number 3. What is this? Match list 1. Soil classification of an aquifer with list 2. Values of the range of hydraulic conductivities in meter per day. So for fine gravels, first one is fine gravel, second is very fine sand, silt, and pure clay. So in case of pure clay, the hydraulic conductivity is very, very low. So in these 4 options, I think this will be the hydraulic conductivity for pure clay. Okay, so D 4. D what? 4. And fine gravel, the highest value for hydraulic conductivity from these A, B, C, and D, the highest hydraulic conductivity for fine gravel. So highest one is third one, 100 to 1000. So for A it will be 3. Okay, and from these two, very fine sand and from silt, the silt has lower hydraulic conductivity as compared to very fine sand. So for silt, this will be 2. So for C, this will be 2, and for B, it must be 1. Okay, so 3 1 2 4, 3 3 1 3 1 2 4. The option will be D. The correct answer will be D. So 3, answer D. Okay, so the now next question is question number 4. Question number 4. Consider the following statement. A well-graded sand should have uniformity coefficient greater than 6. Yes, this statement is correct. Cu must be greater than 6. Uniformity coefficient, that is Cu, must be greater than 6. See, what is Cu? Uniformity coefficient. Cu is D60 by D10. D60 by D10, and it must be greater than 6 for well-graded sand. Okay, so this is correct statement. And coefficient of curvature in between 1 to 3. Yes, this is also true. Coefficient of curvature is D30 square divided by D10 into D60, and that must be less than 3 and greater than 1 for well-graded sand and well-graded gravel also. Okay, so for well-graded sand, Cu must be greater than 6 and Cc lie in between 1 to 3. So this is also correct. Effective size greater than 1 mm. Effective size greater than 1 mm. So, the answer will be effective size greater than 1 mm. This is not the correct answer. Effective size D10. D10 must be greater than 1 mm. This statement is not correct. For well-graded sand, D10 is greater than 1 is not correct statement. Okay. For this, I'm giving a chart. So for this, I'm writing a chart. Please see carefully. Let me clear this first. So chart is like this. Well-graded gravel, GW, well-graded gravel, for soil to be well-graded gravel. First condition is more than half of the coarse fraction, more than half of the coarse fraction must be greater than 4.75 mm, and second is Cu is equal to D10 D60 by D10 must be greater than 4, and third one Cc, that is D30 square by D10 into D60 must lie in between 1 to Cc lie in between 1 to 3, and otherwise it will be poorly graded gravel, GP, poorly graded gravel, otherwise poorly graded gravel, otherwise. Okay, so this is for well-graded gravel and poorly graded gravel. Okay, and for well-graded sand, for well-graded sand, SW for well-graded sand, and poorly graded sand, that is SP, is poorly graded sand, and SW is well graded sand. Okay, for this first condition is more than half of the force fraction less than 4.75 mm. Okay, and the second condition, Cu is equal to d60 by d10 must be greater than 6, and third, Cc is d30 square by d10 into d60 must be lie in between 3 to 1, otherwise it will be poorly graded sand. Okay, so these three conditions must be satisfied for well graded sand. So for well graded sand, uniformity coefficient is greater than 6. Condition 2, correct one. The coefficient of curvature between 1 to 3 is 3. Condition 3, correct one. Effective size is greater than 1 mm. No, that is more than half of the coarse fraction must be less than 4.75. So this statement is wrong. So 1 and 2 is correct. So option number B is the correct answer. Okay. So the now next question is question number 5. Question number 5. What is question number 5? If the proportion of soil passing 75 micron sieve is 50%, and the liquid limit and the plastic limit are 40% and 20% respectively, then the group index of soil will be. So group index, what is group index? So let me discuss in detail about group index. So according to ASTO classification system, according to American Association of State Highway and Transport Officials, AASHTO, according to AASHTO, ASTO, according to AASHTO, ASTO classification system, group index GI is equal to 0.2a plus 0.01 BD plus 0.005 AC. Okay, and this group index GI must be lie between 20 to 0, and as group index increases, the quality of soil for road construction will become poor. Okay, so here what is A? A is that part of percentage, that part of percentage passing the 75 micron sieve, greater than 35, greater than 35, and not exceeding 75, that is x minus 35. Okay, what is B? B is that part of percentage passing the 75 micron sieve, greater than greater than 15 and not exceeding 55 and expressed as positive expressed as a positive whole number whole whole number that is 0 to 40, and this is x minus 15. You can calculate it as x minus 15. And is C is that part of liquid limit that part of liquid limit greater than greater greater than 40 and not greater than 60, not greater than not greater than 60, expressed as a positive whole number positive whole number 0 to 20, and you can calculate it as x minus 40. And what is D? D is that part of plasticity that part of plasticity index greater than greater than 10 and not exceeding 30, expressed as a positive whole number 0 to 20, and you can calculate it as x minus 10. Okay, so in this case this value is nothing but this is 50%, so this will be 50 minus 5 is equal to 15. So A will be 15 and B will be, that is 50 minus 15 is equal to 35. So B will be 35. And what is C? C will be this is that part of liquid limit greater than, so X is liquid limit is 40, so this is 40 minus 40, this is 0, and that part of plasticity index, this is nothing but plasticity 20, so 20 minus 10 is equal to 10. So if you put these values in this expression, you will have 0.2 into A is 15 plus 0.01 and B into D. What is B? B is 35 into 35 into D is 10 and plus 0.005 multiplied by A is 15 and multiplied by C, which is 0. So whole expression will become 0. So this will be, if you multiply this then and add, then this expression will be this is 0.2 multiplied by 15 and plus 0.01 multiplied by 35 is 3.35. This is 3 point into 10, also into 10, so 6.5, and this expression we have, this is 6.5. Okay, So the answer will be this. Furthermore, if we um, if we further describe about group index, then let me tell some points about this. The first point is while calculating group index, if any term become negative, while calculating group index, if if any term become if any term if any term becomes negative if any term becomes negative, it is dropped. It is dropped. Okay, the group index should be rounded off. The group index should be rounded off to the nearest whole number, to the nearest whole number. The next point is if the computed value is negative, it is reported as 0. If group index is less than 0, then it is then 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 it is reported as 0. Okay, next point is in general, the greater the group index value, in general the greater the group index the group index value, the less desirable a soil, the less desirable a soil is for highway construction. Within that subgroup, within that subgroup, a group index of 0, a group index of 0 indicates a good subgrade, good material, while a group index of 20 while a group index of 20 or more indicates a very poor subgrade material, indicates a very poor subgrade material. Okay, and the last point about group index is the group index must be mentioned even when the group index must be mentioned even when even when even when mentioned even when it is 0 to even when it is 0 to indicate that the soil has been classified as soil has been classified per as per ASTO system as per ASTO system as per ASTO system CH-2 ASTO system. Okay, so this is all about group index. So now question number 5 is finished. Now we will take question number 6. We'll take question number 6. This is 5. Let me clear all. Question number 6. This is question number 6. So match list 1 soil and list 2 group symbol and select the correct answer. So first is clay gravel. So clay gravel. So GC is for clay gravel. So A 4, clay sand SC. So B 3 SC, and organic clay is OH, organic clay C OH, high plasticity, organic clay OH, and silty sand D, silty sand S, M for silt. So this is silty sand is 1, COH, this is 2, and this is 1. So 4 3 2 1, 4 3 4 3 2 1. Option C will be the correct answer. Question number 6, option C will be the correct answer. Now we will discuss question number 7. Okay. Let me clear this first. Question number 7. What is question number 7? Let's see it. In question number 7, in a soil specimen, 70% of particles are passing through 4.75 mm IS sieve, and 40% of particles are passing through 75 micron IS sieve. Its uniformity coefficient is 8 and the coefficient of curvature is 2. So in the soil specimen, 70% of particles are passing through 70% of particle is passing through 4.75 mm sieve. 4.75 mm. This is question number 8, not question number 7. This is question number 6. This is question number 8. Where is question number 7? 7 is missed. So this is question number 8. Question number 6. So let me write question number 7. Missed. So let me write it. Question number 7. What is question number 7? It is asked in engineering service 2001. ESE 200. Okay. So question number 7 is based on grain distribution analysis. Based on grain distribution analysis, the D10, D30, D60 values of this is and D60 values of a given soil are 0.23 mm, 0.3 mm and 0.5 41 mm respectively. Full stop. As per IS code, as per IS code, the soil classification will be the soil classification will be option number A SW, option number B SP, option number C SN, and option number D SC. Okay, so solution is D60 is 0.41, D60 is 0.41. Okay, D30 is 0.3, and D10 is 0.23. So from here, CU is D60 by D10. So D60 is 0.41 by D10 is 0.23, and this value is 1.78, and this is less than 4 as well as 6. So this is condition for poorly graded gravel or maybe sand, but this is definitely poorly graded. Anything this is poorly graded. Okay, and CC is D30 square by D10 into D60, and D30 square 0.3 square divided by D10 is 0.23 into D60 is 0.41. So this is 0.954, 0.954, which is less than also 1. So CC is for well graded uh, gravel or sand, it will lie in 1 to 3, but this is less than 1, and this is also less than 4 or 6. So this is definitely the soil will be poorly graded. So there is only one option for poorly graded, and this will be option number B, sand of sand with poorly graded. And why this is sand? Because D60, D30, and D10 all are all the size is less than 4.75 mm. So for sand, the size must be lie between 4.75 to 75 micron. This is mm. For sand size will be line between 4.75 mm to 75 micron. So this will be sand, and it will be poorly graded. Okay, so option number B will be the correct answer. This is all about question number 7. Now we will discuss question number 8. Okay, now we will discuss question number 8. So what is question number 8? Question 8 is saying, in a soil specimen, 70% of particles are passing through 4.75 mm ISC, and 40% of particles passing through 75 uh, micron ISC, and its uniformity coefficient Cu is equal to 8, that is greater than 6. Okay, and Cc is 2, which is also in between Cc in between 3 to 1. Okay, so this is condition for well graded, and it will be what is this, sand or gravel? So let me first uh, see about analyze about let me first analyze about the size. Okay, 70% 70% particle are passing through 4.75 C. So if we take this is 4.75 mm seed, so 70% particle pass, that 100 gram, we have the soil sample of 100 grams, 70% pass, so 30 gram will be retained on this seed, and 40% particle are passing through 75 micron seed. So 40% are passing through 75 micron seed. If this is 75 micron seed, so 40% is passing from this one. So if this is pan, then um, on pan, what is this? 40% of particle passing through 75 micron. So 40% particle passes through this. So this is 40 gram. So remaining this will be 30 gram. This total is 100 gram. Okay. So in this case, um, the fraction of uh, the fraction 50% and 30 and 30. So 50% part in gravel and sand is 50%. Okay, so it may be gravel or it may be sand also, and this is greater than 12%. Fine particle is greater than 12%. So the naming uh, will be the name of soil. Soil have two characters, so dual character. Soil will have dual character. So the answer is not matching from this. So first, what will be the answer? So since 60% particle, since 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 60% particle, since since 60% of of soil, 60% of soil size, 60% of soil size greater than greater than 75 micron, 75 micron, and 60% soil size greater than 75 micron sieve, 75 micron sieve. Therefore, soil is essentially coarse grained. Therefore, soil is essentially coarse grained, coarse coarse grained. Next point, since 40% of soil particle passing through passing passing through 75 micron sieve. This implies that fines are greater than fines are greater than fines are greater than 12%. So soil must have dual character. And in the coarse fraction also, in the coarse in the coarse fraction, sand and gravel, sand and sand and gravel fraction, sand and gravel fraction are are equal, each 30%, each 30%. And the soil can be, hence the soil can be GC, SC, clay off. This is more than 12%. Fines is more than 12%. So it must have clay nature, and it may be gravel or it may be sand also, because 30%, 30% and 30%. So GC, clay with gravel, and SC, sand, clay with sand, or it may be, GM or SM. Okay, um, silty gravel or silty sand, clay gravel or clay sand, silty gravel. That is, this is clay gravel, clay gravel, or this is sandy clay sand. Clay sand is silty gravel, silty gravel, or this is silty sand, silty sand. So none of the option is matching. Okay, so none of the option is matching for question number 8. Now let's discuss question number 9. So what is question number 9? Question number 9 is com in comparison to Atterberg limits of normal soil, the expensive soil have which of the following? So expensive soil have more liquid limit. Yes, this statement is correct. It has more liquid limit. Less plastic limit. Less plastic limit. No, it has more plastic limit as well as more plasticity index also. Less shrinkage limit. Yes, it is correct statement because there is a large volume change for a small water content. A large volume change is there in expensive soil, so the shrinkage limit will be less in this case and more volumetric shrinkage. Yes, this statement is also correct because in expensive soil, the shrinkage and swelling will occur very frequently and in large amount. So 4 statement is also correct. So 1, 3 and 4 is correct. 1, 3 and 4, that is option number B. So 9, option number B is correct. Okay. So 9, option number B. Let me explain in detail. That is expensive soil have expensive soil have first one more liquid limit. More liquid, more liquid limit. So because it imbibes, because it imbibes more water, more water. So its liquid limit is more. So its liquid limit is more. The second one is more plastic limit. More plastic, more plastic limit. So plastic limit is more in expensive soil. Plastic limit is more in expensive soils. Third is less shrinkage limit. Less shrinkage, shrinkage limit. Less shrinkage limit. It shows change in volume. It shows change in volume at lesser water content. At lesser water content. So shrinkage limit is less. So shrinkage limit is less. Fourth one, shrinkage swelling is more. Shrinkage and swelling is more. And fifth one is plasticity index is also more. Plasticity index is also more. And the sixth one is activity is also more. Activity is also more. Okay. So the option number B will be the correct answer. This is question number 9. The next is question number 10. Question number 10. Okay. So match list 1 soil classification symbol with list 2 soil property and select the correct answer using the code given to the list. Soil having uniformity coefficient greater than 6, that is well graded sand. So well graded sand is B. So B1. Soil having uniformity coefficient greater than 4, that is well graded gravel. So that is 2, A2. ML is Silt of low plasticity. Soil having low plasticity. C nothing but 4. C will match with 4. And D, soil having low plasticity, Cl, and D will match with 3. So 2, 1, 4, 3. 2, 1, 2, 1, 4, 3. Option number C. 10, 2, 1, 2, 1, 4, 3. 1 second. 2, 1, GW, well-graded gravel. 2, 1. And ML is low compressibility. Soil having low compressibility and soil having low compressibility and soil having low plasticity. So C and D, the confusion in C and D, having low plasticity, soil having low plasticity, soil having low compressibility. So D will match with 4 because this is clay, and soil having low plasticity, C will match with T. C will match with 3 and D will match with 4. So option number B will be the correct answer. Option number B will be the correct answer. Option number B. Soil having low plasticity. So this is ML. Soil having low compressibility. So this is silt, low compressibility, CL. Clay of low plasticity. CL is clay of low plasticity. So this is clay, so compressibility is less. So this will be the answer. B will be the answer. Okay. So this is all for today. Thank you.